Hi folks, Chuck Black here. We are doing 52 weeks of Python and we are in week number 19. And the topic for this week is named tuples. What is a named tuple? Well, if you're used to referring to different items in a tuple by their subscript, as I'm showing you right here, and you think that's really hard to remember what 0, 1, 2, 3, 4, wouldn't it be a lot nicer if you could refer to them by what data they actually represent, like I'm doing here, device.name, device.vendor, device.model? Then you might be interested in using a named tuple in order to do that. So in this lesson, I'll go through why you might be using named tuples, how to use them, what their benefit is, and then you'll be prepared to use them in the future. So without any further ado, let's get started with the lesson. Okay, so let's talk about named tuples. Now this is a follow-on from the previous lesson where I discussed tuples, and I did spend about 45 minutes talking about tuples, and that was pretty much full. Plus, I actually, by the end of it, I didn't realize that I had forgotten to discuss named tuples. So as I was beginning to do the next thing, which was sets, I realized, oh, maybe I should be going into named tuples a little bit. So that's what I'm going to do at the very beginning of this lesson, which is primarily on sets. I want to introduce you to the idea of named tuples. So what is a named tuple? Well, let's suppose that we wanted to represent a device itself as a tuple. So what I've done is I've taken information from one of our first device lessons, and I just basically created this tuple here called device, and inside it I have item number 0 is a string, item number 1 is a string, item number 2 is a string, 3 and 4, they're all strings. Now you are a smart person, and if you're to look at this, you might be confused as to what this is. It's actually the name of the device. But if you were to look here, you could probably say, well, that's probably the vendor. This is probably the actual model of the device. This is the operating system, and this would be the IP address. You and I can look at that. How would the computer know that? Well, it doesn't really know that, and so it requires intelligence on my part to know that the very first item, which would be item 0, is the name. And so you can see when I print it out here, I'm printing out device sub 0. This is how we reference items in a tuple, as you will probably recall, is using the same syntax that we do for lists, which is square brackets. That's how you do a numeric subscript, and how you do a lot of things in Python. You actually do keys that way as well in a dictionary. But in tuples, sub 0 is going to be the name. I can see that because I'm printing it. Sub 1, which is the second item, is going to be the vendor. So this all works great exactly as I talked about. And you can see I'm referencing these as device sub 0, device sub 1, device sub 2, etc. Now if I was to leave this for a second and go somewhere else, don't look at the code here. I'm just obscuring what we were looking at. Somebody tell me really quickly, what is device sub 3 or device sub 1, or maybe you remember that, maybe device sub 4. The problem is that is not very descriptive in terms of what they actually mean, so it requires you to remember it. And we just looked at it a second ago, and you've probably, unless you have a photographic memory or whatever it's called, eidetic memory, I can't remember what it's called. I guess I don't have whatever that is, but unless you have that type of capability in your brain, you probably don't remember it. And I would say, if I was to say, go to bed and wake up tomorrow morning and tell me what they all are, it would take you a while to put it back together. And especially if you're dealing with something that you're not familiar with. So looking at this, you can kind of say to yourself, well, this is a little bit suboptimal. Is there a better way to do that? And the answer is yes, there is. And the better way to do that is via named tuples. And what I'm going to do now, I'm hoping is, there we go. I'm going to be getting rid of all of these blank lines here, and we are going to actually look at named tuples. Now the first thing that you'll notice about named tuples, maybe it's not the first thing I want to mention anyway, is that it doesn't come for free in the sense that you don't have to import it. You do have to import it. It comes with in the collections package of Python, so you don't have to worry about installing anything, but you do have to import it. So unlike other things like a regular tuple, didn't have to do anything with the regular tuple, but if you're going to use a named tuple, then you need to make sure that you import it. So here we're going to deal with this device as a named tuple. Now, this is how we're going to do it. In fact, I'm not going to show you the how before I show you the why. Look at this. If you were to look at this code and I was to say, what do you suppose that first one is printing out? Even David Bombal could probably say, that's printing out the name. And this one here, it's printing out the vendor, and that one's printing out the model and the OS and the IP address. It's fabulous. It is very self-descriptive, and one of the things that we want to do when we write code is make it as easy to understand just by looking at the code as possible. In fact, if you write code that requires you to write comments in order to explain what's going on, then you may want to think, okay, could I have done that in a simpler way to make it easier for the next guy who's going to be looking at this code to understand it. And this is very easy to understand. Device.name, device.vendor. In fact, if you'll recall the way that we did things, let me pull this up. I haven't looked at it in a while. Let me make sure that I have it. Well, I don't actually have a great example of it because I'm actually iterating through it. So I don't, well, here's one case where I specified device subname. Look at how I have to do device subname. Look at all the extra typing I had to do. I had to do brackets, and then I had to do an actual string that identified the key, because this is what? It's a dictionary. This is my dictionary here. So you can see that doing it like this, or tuples, is actually a little bit more straightforward and easier to, it may or may not be easier to read, but it certainly is easier to write. And I will tell you that people have called named tuples something like a poor man's class, because when you get into object-oriented programming, you may or may not have seen this before, but when you do this dot notation, that usually is an indication that you're referring to a member within a class object. And so here we're getting to do that. Now, how did we accomplish this so that I could do that with device? Well, this is what we had to do in order to make it happen. Now, I'm going to pause here for a second, and I'm going to say, all right, this is a kind of a clunky way that we are required in order to make this happen. First, I have to create this thing called a named tuple. I have to repetitively tell it that it's device. And then I have to pass in these things, which, unless you understand what they are, you kind of don't really have, it's not really self-evident what this is doing right here. And then when I set the data, this is how I actually set the data. If you're familiar with object-oriented programming, you can say that looks like what you would pass to a constructor. And if you're not familiar with that term, that's fine. But it's how you actually create an instance of the thing. And you're absolutely correct. That is exactly what it's like. Now, I'm being a little bit disparaging about what you have to go through, specifically in this declaration of the name tuple. You have to do that in part because of the way that Python's typing of variables works. It's not statically typed language. It's dynamically typed, or as we sometimes call it a little bit humorously, duck typing. In other words, if it walks like a duck, and if it looks like a duck, and if it quacks like a duck, then it must be a duck. So you don't actually declare things in Python. Python infers from the way that you use it what the data type is. And so that is in other languages like C or like Java, you would have declared this to be the way that it is early on, and then you would have just assigned data to it later on. But because of the way that we do things in Python, this is required. I don't want to get in any arguments with any Pythonistas out there who will claim that because Python is the greatest thing in the world and walks on water as programming languages go, and there's nothing better than it, that this is absolutely the best way to do it, and they won't listen to any argument otherwise. I don't want to get into any arguments about that. Let's just agree that for me, Chuck Black, this looks a little bit clunky, but once you get used to it, it may become a little bit easier. So here's what I did. Now I defined my named tuple thing with a capital letter. You see this capital D? And I think I've mentioned it. I get confused whether I mentioned this in my Quokka walkthrough or if I've actually alluded to it at all in the 52 weeks of Python. Whatever the case, you notice in Python what we normally do is we have things that have all lowercase, and we separate the different portions of the variable name that might be called the words or the different parts of the variable name with this underscore thing. We call that snake case. What we do in with dealing with classes in Python is we use what's called Camel Case, where you just capitalize the first letter. So this would be, if this was a class, it would be capital C, R-E-A-T-E, without an underscore, capital D, E-V-I-C-E-S. That's why we call it Camel Case, because it kind of has humps in the middle of it. We call it snake case because this underscore, I guess, is like a snake slithering along the ground. Although hopefully it doesn't do that. And if it does do that, then you may want to lay off of the mind-altering controlled substances that you've been imbibing. All right, so enough of that description. Named tuple. Here we are back. We're looking at how we define it. The way that you define it, and I'll let you look this up if you're interested in using it, but you basically give it the name of the thing that you are going to be referencing. And every time I've used this, I've actually never used it. I've never used named tuples in actual production code. That's probably because the people that I hang out with are used to writing Java or Scala or Go or C++ or other languages rather than Python. And so they're used to using object-oriented stuff. So instead of using a named tuple, they would probably just define a class called device, and we would do that instead. And so the stuff that I've done is more object-oriented. But if you don't want to go the whole object-oriented, then a named tuple can give you a lot of the benefit of it. So this is what you do. You define, you specify the name of the thing, and then right here, here you are referring to, you are providing a list. You can see this is a list because it has square brackets, and each one of these strings is going to be the actual name of the field. Look at these things right here. Name, you see name, that's the same as this name right there. Vendor is the same as vendor. So the things, the way I'm going to refer to it are these values right here: name, vendor, model, OS, and IP. And then what I do, and so this is defining the thing called device. Now when I want to create a variable that is a named tuple that actually has values, then what I do is I pass this information in this manner. I'm doing it in a positional manner. I actually haven't looked this up because I'm not super familiar with it. I suspect you can use keywords as well, and the keywords would be those. I don't know that for sure. If you're interested, you can look it up. Probably a good thing to do a simple Google search to figure that out if you are interested. But you can see this, the name corresponds with that one. The second one, Cisco, is the vendor. And so when I print this out, you would expect me to get those values. And I'm going to go ahead and run this, and we will just look, and let's ignore all of that stuff. This is what I did before. This is the code that we looked at in the last lesson, so ignore that. Here's my device as a tuple. So that's this thing right here. Device as a tuple. I just created a device, and then I printed out sub-0, 1, 2, 3, and 4, and that's what this looks like. And then I did device as named tuple, and I printed it out here using the actual field name, member name, whatever you want to call it, the dot notation, and you'll notice that this data hopefully is exactly the same as the data above it. And that's how you would use named tuple. And I'm going to go into a little bit more detail and show you a way to do some conversion from what we've done in the next segments. So continuing on with this named tuple stuff, I thought, hey, why don't we get PrettyPrint to print out our device? Remember, our device is this named tuple that we created. It's got these fields or members or whatever you want to call them, called name, vendor, model, OS, and IP. And so thinking that it would print it out nicely, I did PrettyPrint of device. And let's look at what happened. I'm looking for pprint of device named tuple, device named tuple. I should have put that as one word because it sounds like it's a device named tuple. That would be pretty silly to name your device tuple and confusing. So yeah, let's just, anyway, I do that all over the place. Let's ignore it for now. But I'm distracting myself again. PrettyPrint of device. I was expecting it to print it out something like I printed out up here, of course not with that type of formatting, but in some manner. What it actually does is it's just printing out this thing because in Python, or in PrettyPrint's mind, this is just one thing. It is a tuple. It is a named tuple. So it's not going to do the nice nested data structure printing out when we see lists of dictionaries of lists of lists of dictionaries, etc. And so when I look here at what it printed out, I can kind of read it. This is it, but it is just one thing. It didn't really format it. In fact, I went ahead and tried this. Let's say that I just wanted to print it. I'm going to come over here and get rid of the PrettyPrint, and I'll leave that comment there because I'm going to put this back. I'm going to run this, and we will look at the PrettyPrint, which isn't really a PrettyPrint, and it's exactly the same thing. It's just a listing of the device. So there's no value in PrettyPrint, but I'll leave that in just so you get the idea. So when it's printing this out, it's like it is almost a class that it is printing out. So it's got this capital D device, and then inside the parentheses, let me make this a little, oh yeah, it's big enough. Inside the parentheses, you can see all of the data that is inside it. So here I have the name, and then the equals value, vendor equals value, model equals value, etc. So it did indeed print it all out for me, and that's good, but just want you to be aware this is what you're getting with a named tuple. It's something that is kind of a higher level object than just a dictionary or a list or a tuple, and so it lists things like this. But the good news is associated with this item 0 is an actual a name for the field. That just happens that it's called name. Here's the name for this field, which the name is vendor. Here's the name for this field, the name is model, etc. All right, so let's go to this next thing, and there's a couple of things that I want to point out as I do this. I thought to myself, wouldn't it be nice if I could take this create devices function that we've written a while ago? You remember we've imported it, we used it up here when we created a tuple out of it. And that's, in that situation, what did we do? We didn't make every single device be a tuple, right? We just created the whole thing as a tuple. So look closely. There's a surrounding round brackets, but inside it, every single device is what? Look at the curly brackets, look at the colon. Every single one of these is a dictionary. So it's a tuple of dictionary items. The dictionaries are representing devices. And so that's what my create devices is. And what I said was, why don't I see if I can change those dictionary items into named tuples? Is there a way to do that? It seems like there should be, right? This should become like IP equals that and name equals that. I tried to figure out a way to do that. Before we go into that, those of you that have eagle eyes might be looking at this and say, wait just a doggone minute. What is this random IP thing, and why is it true? What have you done to my original create devices? And in order to answer that, I have to tell you that I was originally planning on doing sets next as my next lesson. And so I began to work on doing sets. In order to do sets, I modified create devices to make it a little bit more interesting. And I said, okay, I'm going to allow you to pass in a parameter that says random IP equals true. And so this is going to tell create devices that, hey, this I want you to generate IP addresses randomly. I don't want to have them just go 1.1, 1.2, 1.3, 1.4, etc. And if you actually look ahead at the data that we're printing out, there's the data that we're printing out. That actually looks kind of cool, doesn't it? So we've got all these different IP addresses in this IP list of these devices, and it looks a little bit more realistic, frankly. You could sort based on it, but I just have generated those randomly. So that's what that is all about. If I was to go here and we were to peek down into it, you can see by default random IP is false, so everything that calls random IP is going to work exactly as it did before. When we go down to create device, I'm going to be passing forward that random IP, and random IP, if I drill down into that, you will see at the very bottom here, everything's the same except I have this random IP. And this is what we used to do always, was I just use the subnet index and the device index, which just got incremented by 1. Here I say, get me a random IP address for this subnet. And we will be looking into that when I do sets. We're not going to do that right now. So let's go back to our named tuples, and hopefully you'll know that what I've got now is a list. Remember, this is returning, create devices returns a list. I had to convert it into a tuple in order for it to print out as a tuple like it did at the beginning. So here I'm saying, give me 10 devices per subnet and 2 subnets. And after I have got these devices, I'm creating a new variable, and I'm calling this devices as named tuples. And so in this situation, I'm going to have a list of devices, but each device is going to be a named tuple. And if you're peeking ahead, you can see devices as named tuples. Here's my square bracket for a list. Here's the tuple values. All right, so this is just printing it, not attempting to do anything terribly interesting. So I have actually succeeded in doing that. So let's look at what I actually did here. I have a simple little for loop. I've done a create devices. I have devices, which is a list of devices. Each device is a dictionary. So what I'm going to do, and how did I know to do this? The same way that you will be learning how to do stuff, which is I Googled it. Since, as I mentioned, in the real world, I haven't actually done tuples myself. So I had to look it up and figure out, okay, how am I going to do this? And so here, and we will compare this to what I did before. Let me make this a little bit bigger so you get a little bit of an idea. Here I'm saying device equals name tuple. That looks the same as what I did up here, right? Device equals name tuple. And in fact, this first part of it, device, is exactly the same as that. The only difference that I'm noticing now is that I have used single quotes. Doesn't make any difference if you use single or double quotes as long as you use them consistently. So I have double quotes, device, it's a string. And then remember, this was a list of the actual fields that I was going to have in my named tuple. And for those of you that are sticklers for using the right term, I actually have not looked up whether I should be calling those fields or if there's an other word that may be of interest to you. For me, in my professional life, well, I've never used named tuples in my professional life, but I find that most people are fairly comfortable as long as what the term that you're using is understandable, sort of similar to the idea of parameters versus attributes and the correct usage of that. Somebody has pointed out to me that people who do tests can be very, sticklers for accuracy. And so I may just point you to say, okay, well, you can look this up. Good exercise to figure out what are the things that are parts of a named tuple called. Are they called fields? Are they called members? What do we call them? So, but whatever they are, that's what it looks like here. Here's a list. Now, what am I doing here? Let's slow down, because your initial, especially if you're new, you may say, that is pure mumbo jumbo. I have no idea what you're doing. So let's slow down. Let's find the parts that we do understand. Device. What is device? Device is the thing that we are iterating, the item that we've gotten through our iteration of devices. Devices is a list. The list is made up of individual device data, and that device data, if you will recall, is going to be what? What's this data type? It's a dictionary, okay? And a dictionary is made up of what? It's made up of key value pairs. So when I say, if I'm going dictionary.keys, even though you may not have ever done this before, what do you suppose that returns? Well, you might say, I suspect that it returns a list, and that list is going to be the keys. So it will be a list that has the string IP, the string name, the string OS, the string vendor, and the string version. And you'd be absolutely correct about that. That's what I'm getting right here is a list. And once you know that, then you can say, oh, hey, this is exactly the same as what I had here. What is this in general terms? It is a list of strings, where strings are going to be the names of the fields. And when I do device.keys, what do I get back? I get a list, and that list is going to be consisting of strings that are names of the fields. All right? So basically now I've created a named tuple, and it is going to have the names of our fields. Now it's going to have IP, name, OS, vendor, and version. You'll notice that's a little bit different than what I did up here. I took this from the very first lesson that we did. Create devices creates devices with this set of information, these 5 different items: IP, name, OS, vendor, and version. So that's what we should be looking for when we continue down here. Now what I'm going to say is this, and again, you may look at this and say there's just too much there for me to understand. Well, let's start with what you can probably figure out. Devices as named tuples is what? It is a list. What do you do to add something to a list? What method do you call? What function do you call on top of that particular list? You call append, the append method. And that is going to append something to your devices as named tuples list. What is it going to append? Well, it's going to append a capital D device. What is a capital D device? Oh, it's a named tuple. So I'm going to end up with a list of named tuples. Now, how am I going to create the data in this named tuple? And if you recall, if we look up here, this is what we ended up doing. We just passed in this data, and it magically created the device.name with the first item, and device.vendor with the second item, etc. And I asked a question before that I wondered if you could use keywords here, and I'm about to answer that as I go through this. So let's look at device. Remember when I said device, I'm going to be creating a named tuple called device with this data in it. That's what I was doing up there. Now I'm going to be creating a named tuple called device with this data in it. All right? I'm going to be creating it with this data inside it. Now we need to figure out what exactly is this data. And this is more, I would say, intermediate to advanced. This is something that you will see that I have done regularly in my SQL Alchemy stuff for Quokka, the application. What this is doing is this, and I'm going to kind of wave my hands because I don't want to do a deep dive into it. But what this is going to do, what is device? Let me ask you. Remember, we went through devices. Devices is a list. Every device is a, look over here on the right, it is a dictionary. What this is going to do, it's effectively going to take this dictionary and it's going to convert it into a keyword and an equal sign and the value. Think of it that way. It's going to create keyword arguments. In fact, if you say something, and I'll try to put this, this is not what I'm intending to talk about, but if you see this, KWARGS, I'm just going to print it right here. If you see KWARGS, you can Google that and you can say, what are KWARGS? I'm going to explain it to you. That stands for keyword arguments. It's basically passing in these arguments or parameters, depending on whether you want to call it by the KWARGs or the word parameter, as we've talked about. It's going to take this dictionary and it's going to convert it into IP equals the keyword, the name IP equals the value, the keyword name equals that, the keyword OS equals whatever this might be. And it's going to pass that into device. And then it's going to go and it's going to do this how many times? For every single device in our list of devices. Okay? So I know that's a fair amount to digest. If you're new, just try to remember bits and bobs about it. If you're intermediate to advanced, then you probably need to understand this. So you'll want to, just take a minute and digest this fully. Now, before I leave this and move on to the next thing, I want to point something out to you. Do you notice that PyCharm is giving me a bunch of squawkiness here? It's squawking about this, it's squawking about that, it's squawking about that, and that, and that. So I'm leaving this here because there are times, PyCharm in general, probably 95% of the time, the thing that it warns me about, I definitely need to be warned about. Like as I was writing this code, I did something incorrectly. It was warning me about it. It was syntactically okay, so it didn't throw an error, but it was warning me about something, and I realized, oh, I did that wrong. So in general, you want to pay attention to what the great PyCharm in the sky is telling you about what you have done. In this situation, however, what I've done is perfectly okay. How I'm referencing it here is perfectly okay. I haven't taken the time to go and look into this. Maybe I'll do that after I'm done recording this. But I just wanted to make sure that you're aware of that, and normally it's something to pay attention to. But certain times, and this has happened in production code for real projects that I've been in, sometimes PyCharm just isn't aware of certain things that you end up doing that are perfectly okay, and they're even okay in the PEP 8 guidelines, which is the overriding guidelines for how your code should look in Python. So this is what I've done. This is what I've created. In just a second, I'm going to go through and we're going to look at exactly what got created. I'm going to print the stuff out. So the last thing I'm going to do here in my named tuple stuff is that I'm going to print it out. The first time I'm just going to do a pretty print. Remember devices as named tuples. That's what I created and appended these named tuples to. Once I converted device, which was a dictionary, and passed the keyword arguments into device so that it could create it appropriately. So I do a pretty print, and then down here I just copied this code from other code that I have here in this situation. I'm modifying what I'm printing out to be printing out device.name, device.vendor, device.os, device.ip. Just think about this. If we had been using a regular tuple, this would have been device sub 0. This would have been device sub 1. This would have been, I don't even know what OS is, device, I'm not doing models, so this would be device sub 4, maybe. I can't even remember how I had it set up. And then this would be like the 4th or 5th one up here. Anyway, you get the idea. I would be at the mercy of remembering what the actual subscript or index would be. But instead, I'm using a name tuple, very self-descriptive, device.name, device.vendor, device.os, device.ip. See how easy that is? Once we evolve and continue to grow in our skills, we'll be using classes where we see this all the time. But for right now, name tuple is the thing that brings it to the table for us and that we can use. So let's take a look at what gets printed out. Here is my pretty print version of devices as named tuples. So remember, when we looked at just one of them, it looked like that. But in this situation, what do I have? I have a list. So I have my square brackets around it, and it's printing out each one of these. And inside, it nicely tells me name equals whatever. This is effectively like keyword arguments, what it gets translated into. OS is the keyword or the field version, and then IP. So all of these things are listed for us, but that's not very pretty. You wouldn't want to show that to your boss. You might want to do something like print it in a nice format. And as you can see, I used the F string in order to do this. And let's have a look at what it looks like. It should look familiar to you for the way that we've seen it before. Yeah, these are the device names, and then vendor and OS. I'm not sorting anything, so it's in exactly the order that it got put in. So I haven't attempted to do a sort. I suppose I could sort on vendor, and that might be more interesting. I could sort on the IP address. That might be of interest as well. But so there you go. That is how you use named tuples and why it's of value. Hopefully this description has been informative for you. Like I say, I'm not sure how often it's used in the wild. I actually was planning on looking into this online just to see how much people like doing this, or if they go directly to using classes instead. And I suspect the computer sciencey type people will use classes, and maybe the network automation people who are coming from a network engineering background like named tuples. I'm not 100% sure, but I figured I would present this to you anyway. So yeah, hopefully that's useful. Okay, so let's quickly review what we talked about. We created a tuple of a device and showed how if I wanted to print out name, vendor, OS, IP, then I need to refer to these items by their subscript, which can be pretty hard to remember. And so we talk about the idea of a named tuple. And the nice thing, if you look down here, is I can do device.name, device.vendor, device.model, etc. And it's much easier to read. How did I do that? I imported named tuple, and then I created something called the device, and you can see me referencing the device here. I'm passing in the name and the vendor and the model, etc. and printing it out. It shows that when you do print it out, it is actually this device type thing, and it's got all that data and information in it. Doesn't really look all that nice printed out, but there you go. You can reference it like this. Then we talked about, okay, well, let's use our create devices function and change all of those devices that are in there, which are dictionary items, into named tuples. And we did that using this mechanism. We did device.keys, which operated as basically the names for the fields, as you see here. And then we created for our named tuple list that we're creating. We took device and we passed it in. We actually passed in the keyword arguments to our device named tuple. And as we can see, we ended up with a list of a whole bunch of these device items based on the dictionary. And then this is the version of me just printing it out. So named tuples can be useful. You can see how much wonderfully easier it is to read something like this. and to read something like this than it is if I was using subscript. That's what they're used for. Hopefully that's been helpful to you. You have a better understanding of named tuples, and you'll be able to use them if you choose to do so.